Okay, so today we're going to be talking about measures of spread. It's going to be a couple things called, so we're going to talk about standard deviation, quartiles, and something called z-scores, which seems like a silly random name, but it's going to be actually pretty relevant for the next unit. So, for example, let's say we have two data sets. We're going to have this thing I'm going to call data set A, and this one I'm going to call data set B, which are not very evocative names, but they're names. So let's say this set is 6, 8, 10, 10, 11, and let's say that this one over here is 2, 4, 10, 13, 16. So what I'm going to do is I'm going to find the mean and the median. So the median, as you may or may not recall, I'll use a different color for that. Here we go. The median, sorry. So the median is the middle number. In this case, it's 10. And the median number over here is the middle number, which is also 10. And the mean, and you may remember that the symbol for mean is this kind of it looks like a U, but it's actually a mu. So mu, mu. So the mu is 9. And we had those up and we divide by 9. Here, I'll get my calculator. The way we find the mean here, of course, is we add them up. 2 plus 4 plus 10 plus 13 plus 16 equals, divided by 5 is 9 as well. So what we notice is when we talk about averages for data set A and data set B, they're both the same. They both have the same median, they both have the same mean, they both have the same average. But they're pretty different, right? So the numbers in data set A are fairly close to each other. The numbers in data set B are fairly spread apart. And I'm not just talking about the lowest to the highest. Even like if you look, these are more spread apart and these are closer together. So what we're going to have is we're going to have another way of measuring. We're going to have a way of, essentially the title of the lesson, we're going to have a way of measuring spread, how spread apart things are. So how are we going to measure that? So we're going to have some terminology here. So what we're going to have is we're going to have this symbol over here. And this symbol over here is a sigma. It's a lowercase sigma, actually. So we had an uppercase sigma before, that was an uppercase sigma. That's not what we're doing now, it's a lowercase sigma, and it's definitely different. And this stands for the standard deviation of a population. And kind of the way of describing it, like the kind of non-mathy way of saying it, is that it's the average distance from the mean. So it's the average distance from the mean. So for example, if things are close to each other, then they are, so when numbers are not spread apart, they're very close to the mean. So these numbers are closer to the mean, and these numbers over here are farther from the mean. So that was the average distance from the mean. Sorry, my daughter was asking something there. Okay, so it's a measure of spread, and what it is it's something called a root mean square deviation. So root mean square deviation. So when we take an average, the way we've taken an average basically your entire life is you add up all the numbers and you divide by the total number of numbers. It turns out that's not the only way to take an average. There's different ways of taking the average, and one of those ways is called the root mean square. And we'll get to that in a second. I'll show you exactly what it is. But the standard deviation over here, that sigma, is a representation of the spread. And the bigger the sigma, the bigger the spread. And we may have a situation where we're finding the standard deviation of a sample, and the symbol for that is an S, which is a lot less exciting. But that is what it is. So there's a formula for standard deviation. It's an actual formula for standard deviation. So the formula is going to be, so we're going to define some variables first. So x is going to represent each item in the set, or each data point. Right, so before when we had the set, oops, wrong one. That's an x, that's an x, that's an x, that's an x, that's an x. So there's 5 different x's there. And n is going to be the number of data points in the set. So what we're going to have is our formula is going to be sigma equals the square root of the sum of x minus mu squared over n. And that's the formula, and that is what we are going to be talking about shortly. So for example, let's say we had our set from before. So our set from before was 6, 8, 10, 10, and 11. What we're going to do is we're going to use this formula over here. So the first thing, we're going to actually make it kind of as a table. Is this going to fit this table? It might. So the table's going to have x and some other lines. So x is going to be, we're listing all the values. 6, 8, 10, 10, 11. So 6, 8, 10, 10, 11. Now if you look at the formula, what we have to do with each of these values is we have to subtract the mean. Now you remember from before that the mean was 9. So what we're going to take is each value is we're going to subtract the mean. So 6 minus 9 is negative 3, 8 minus 9 is negative 1, 10 minus 9 is positive 1, and positive 2. By the way, if we added up these deviations, we would end up with 0, which makes sense because on average, everything is, the sum has to be that. That didn't sound totally obvious now that I said it out loud, but it is. Then if we look at the formula, we're going to take these deviations and we're going to, so this is the deviation column, and we're going to square them. So that does two things. A, it makes everything positive, and B, it kind of weights things that are farther from the mean a little bit more. You don't have to know that. I'm just saying that as a point of interest. Then what we're going to do is, that's the sum of symbol. That's a sigma. So we're going to add up the deviations squared. So we're going to add up all these values. So the sum is going to be 9 plus 1 is 10, plus this is going to be 16. So now, when we look at our formula, it's going to be the square root of the sum of the deviations squared divided by n, which in this case, the sum of the deviations squared is going to be 16. The n is going to be 5. So it's going to be the square root of 3.2, which I cannot do in my head. And so the square root is 1.79. And that's it. So the standard deviation for this set is 1.79. Now let's say we want to do the standard deviation for the other data set. So the other data set was 2, 4, 10, 13, 16. So what I would recommend, normally what I would do in class is I would let you guys work it out. So I would pause the video and try to work it out yourself. And hopefully now you've already worked it out and you're just seeing that you're just checking if you got it right. So I'm going to go through this pretty quickly. X minus mu's squared. So our numbers are 2, 4, 10, 13, 16. The deviations are minus 7, minus 5, plus 1, plus 4, plus 7. Squared is going to be 49, 25, 1, 16, 49. Add those guys up, we're going to get 75 plus 16 plus 49 is 140. And so the standard deviation here is going to be the square root of 140 over 5, which is the square root of 28. And then the square root of 28 is 5.29. So remember, the deviation before that, for the previous one, the deviation was 1.79. So the deviation of this is less than the deviation of these guys. And remember, the standard deviation represents, again, the average distance from the mean. So on average, the first data set was about 1.8 away from the mean. And for the second one, on average, they're about 5.3 away from the mean. And when I say average, it's not really a full average. It's this kind of root mean square average thing. So we'll do some examples in the next video.